That's what we're getting at with the
They
scale
come
factor.
in many different shapes
Yep.
and sizes.
That's what we're getting at with the scale factor. So it's got to be more than just angles, right?
A rectangle traveling with you.
All right.
They come
So our goals today. We did that already. To identify and apply similar polygon property. To identify and apply similar polygon property. So today we're going to talk just about similar polygons. All right. Later in the week we'll talk about similar triangles.
similar polygon properties.
Similar polygons. And to continue, we'll start with the definition. Two polygons are similar polygons if corresponding angles are congruent and if the lengths of corresponding sides are proportional. The length of corresponding sides are proportional.
Proportional. Oh, shoot. My pencil.
Okay.
Oh, God.
Similar to CPCTC.
Can you go back really quick?
What?
Can you go back really quick?
You guys got to kind of write a little faster? You're just filling in words?
Okay, you're good. Thank you.
All right. Similar to CPCTC and that congruent triangles in that letters match up. In that letters match up. All right. So in other words, when we use CPCTC, we said angle A was congruent to angle B and such. Similar idea here. All right. So for example, we would say that, oh, that's going to be different. We would say angle A is congruent to angle G and thus. The difference is going to be, instead of sides being congruent, they are proportional. So that's the formulatic definition. AB over GH equals BC over high equals CD over IJ equals AD over GJ. So instead of using CPCTC to identify congruent sides, we are going to use it to identify proportional sides. And then using what you did last week, when you reviewed ratios and proportions, we're going to find side lengths. So part of this unit is going to be more computational. There are some proofs, all right, which we will begin discussing, like I said, maybe tomorrow, maybe on Wednesday. Okay? Everybody got it? Okay. This is an example of what we call an extended proportion. All right? If you want to write it down, fine. If not, I understand. An extended proportion simply means more than two ratios. We use it when we use what? Law of sines. Good. An extended proportion.
I guess that's why you assigned this 7.1.
Not just a hat rack, buddy. Yep. And I'm hope, like I said, I posted the solutions this morning. If you go back and there's something you don't understand, feel free to message me there. But that's kind of something we expect you to know walking in the door.
Speaking of something I know.
Uh-oh.
One of the problems on homework, for mine, it said, I think it was like 20 something in the upper 20s. It said like x minus 1, x plus 1 over x plus 1 equals, what was it, 10 over 14? Yeah, for some reason mine
I
said
don't know. I don't
10
remember
plus
all the
1
time.
over 10 plus 1. Wait,
Okay, it might have been in the copies
10
you
plus
got.
1. That's it,
Might have been in the one you got. Might have been in the copies you got. As well. If it doesn't match up, it's not a big deal. It was just to give you an overview. Okay. All right. So being able to identify, what do we know if they tell us triangle MNP congruent to triangle SRT? What do we know is true? Number one, angle M is congruent to angle S. Angle N is congruent to angle R, and angle P is congruent to angle T. All right. Now, when we deal in the same triangle, obviously we're going to have to expand that from 1 letter to 3 letters, but more on that later in the week or the beginning of next week. All right. We also know that MN over SR equals NP over RT equals MP over ST. All right. That homework, I believe, because that's part of your homework, being able to identify congruent angles and proportional sides. I'm trying to see that. And that's through the monomer midnight, I believe. Yeah. So everybody good with that? Identifying congruent angles and proportional sides. Yep, it's up there. Just do the mark. All right, so that's up there. Okay. So next up, determining if polygons are similar. All right, determining if polygons are similar. Utilizing the definition, we must conclude that all angles in one polygon are congruent to the corresponding angles of the second polygon. The sides are proportional, which means we can set up an extended proportion where all 4 sets of ratios are equal. 4 is interchangeable. That's if it's a quadrilateral. If it's a triangle, then instead of 4, it would be 3. If it's a pentagon, it would be 5, and thus.
And of course, what exactly am I looking at here?
What?
There's a picture here.
Yeah, he's determined.
I guess.
All right.
Self realization. 3, 2, 1. Oh, I get it.
I get it. Okay.
Oh, I get it. Okay.
All right. So now some problem solving. All right. Okay. So we'll start with these two where it says determine whether the polygons are similar. If so, write a similarity statement and give the scale factor. Okay. So the first thing we look for is the angles. All right. And then over there. So our corresponding angles congruent to each other. That's, oh gosh, forsaken. Lulu. Make sense? This, friends, is a parallelogram. So instead of all 4 sides, since opposite sides are congruent, you only need to set up, well, how many? 2. All right? And you can do it in a multiple of ways. One way is 3 over 6 versus 4 over 8. All right? That approach would be short side over big side, short side over big side. The second approach would be 3 over 4 equals 6 over 8. It doesn't matter which one you pick. All right? It doesn't matter which one you pick because there's only 2. Now, when it's an extended proportion, it's going to matter. Okay? When it's an extended proportion, it's not going to matter. Now, when we say proportional thinking, we can go about it 2 ways. Proportions mean what? We can always do what? Cross, multiply. 4 times 6 is 24. 3 times 8 is 24. Do they cross multiply to be the same number? Yes. And the answer is yes, they are similar. And that's all you have to do is show for work. Or in your head, you can simplify both fractions. What does 3/6 simplify down to?
1/2.
What does 4 over 8 simplify down to? It's also proportional. All right. So everybody here and at home, work on number 4. No, they're not. And there's two reasons. Number one, are they both right triangles? Yes, but do they give you the other angle measures?
No.
So you don't know that the angles are congruent. Angles, not congruent. All right? But if you try to set up a proportion, you can go 8 over 12, short leg over long leg, equals 3 over 4, short leg over long leg. And when you cross multiply, you get 36 and 32, not equal to each other. All right? 36 and 32, not equal to each other. All right?
I did 8 over 12 versus 3 over 4.
That's fine. All right, whatever gets the job done, my brother. All right, number 5 in the top of the next column. Are they both rectangles?
Yeah.
Yes, so we do not need to check angles, and it is a rectangle, so opposite sides are congruent. So if I look at 4 over 10, that would reduce down to 2 over 5. If I look at 3 over 8, that would only be 3 over 8. Are they equal to each other?
No, they are not.
No, they are not. Therefore, they are not similar. All right? Number 6. Now, once again, we have a triangle. The difference is they give us 2 angles. So do I have the means of getting the third angle?
Yes.
Yes, I'm going to add up and subtract from what? 180. 49 and 88 is 137. Take that away from 180 and I got 43. Now, here's the thing. There's 43 and there's 43. So with that alone, do I know the angles are going to be congruent? Yes. All right, so you should only have to do it once. All right, now I check out the sides. All right, the smallest side over here is 6. The smallest side over at the other one is 4. Equals the middle side of the bigger one is 9. The middle side of the smaller one is 6. And then the biggest one of the bigger triangle is 12. The biggest one of the other one is 8. Now we cross multiply 9 times 4, 36. There's no third triangle, it's third side. It's not a third triangle, it's a third side. All right? So 4 times 9 is what? If you want to go that way, or we can just cross multiply. 4 times 9, 36, 6 times 6. Good to go. 9 times 8, 72. 12 times 6, 72. Or we just all reduce them down. 3 halves, 3 halves, 3 halves.
That's what I did. So, yes, they
So yeah,
are.
we will eventually show you triangles. You only need one or the other. You don't need both. All right? So everybody good with that idea? All right. So then let us take a look at the next set of notes, which is, nope, not homemade example. If they are indeed similar, then the relationship between the sides has a name. The scale factor is the ratio of corresponding linear measurements of two similar figures, which you have most likely done with maps or something else. Maps. So if a map says 1 inch equals 200 miles, can you figure out how far two cities are on the map? Yes, that's scale factor. The 1 inch to 200 miles is your scale factor. Okay? The scale factor is the ratio, of course.
1 city to another city is 5 inches, they're 100 miles.
100 miles apart. Or 1,000 miles apart. You got it. All right. So, homemade example. ABC and DEF are two similar right triangles. The side lengths of ABC are 9, 12, and 15, while the side lengths of DEF are 15, 20, and 25. What is the scale factor between the two similar triangles? Now, they're already telling you it's similar. All right? They're already telling you it's similar. All right? So all you have to do is take a pair of corresponding sides. All right? So in other words, in ABC, the smallest side is 9. In DEF, the smallest side is 15. And then simplify that as necessary, 3 over 5.
That's it.
That's it. If we had taken the longest sides, 15 over 25, guess what we'd still get? 3/5.
It doesn't matter which one you do.
That's what we're going to talk about next. Okay? And Michael brings up a good point. They said, what is the scale factor between the two similar triangles? All right? And the point Michael's making is this, and you have all this spot, all this space down here to work on. And that's what we're going to talk about for a few minutes. All right? When they say, what is the scale factor? Order doesn't matter. All right, so that's what Michael was just talking about. So if they just say, what is the scale factor? Order doesn't matter. Let me get this up there for everybody at home. All right, what is the scale factor? Order doesn't matter. All right. When they say, what is the scale factor of A to B? All right. When they say, what is the scale factor of A to B? Whatever comes second goes in your numerator. Whatever comes first goes in your denominator.
And order doesn't matter.
Now order matters. So when they give you specific things to talk about A to B, that's what you're going to do. All right? So when you go back to this problem, and it says, what is the scale factor? You can either go with 3/5, or you can go with what? 5 over 3. Both of them would be correct. But if the problem says scale factor of A to B, then you have to worry about it. Keep going, Michael. I need your help right now. Take care of some business. There we go. Now I feel better. All right. Now I feel better. All right. So if we're looking at a problem, all right, if we're looking at a problem solving using similar polygons to find missing side lengths,
Oh boy.
all right? Set up the extended proportion filling in side lengths given to you in the problem. Use proportional thinking. Use proportional thinking to find the missing sides or variables.
I was about to say angles.
No, variables. Because the missing sides, you're not going to use proportions to find angles because they're going to be what? Congruent. You're just going to match up letters. Okay? So if I'm looking at this problem, all right, and it's not going to matter the order in which you do it. I'm just going to call this small, and I'm going to call that large. That's how I'm going to distinguish between them.
Alright. So, how do you
You can do it in a multiple of ways, Michael. Okay? Now, if I take the small one, pick anything you want from the small one, either a variable or number. What do you want it to be?
I would say a number.
Okay, so you want to go with 4?
4 over.
Hold on with the over, slow down.
Hold up.
Now you're going to go to what, possibly? Y.
Y.
Okay, and then you go to 12. And then you go to X. All right? All right, so 4, Y, 12, and X.
4, 5, 12.
Now, in the other polygon, 4 has the 4 arcs. What corresponds to 4 in the other polygon? 6. Okay? What corresponds to Y? 12. What corresponds to 12? 18. What corresponds to X? 9. All right. So basically what you need is one of two things. The most important thing you need is one ratio that's made up of what? Numbers. If not, we're going to deal with quadratics later on, but that's the idea. That's what you want to do a straight linear one. All right, so if I cross multiply, 4 times 12 is what? 48. 48 divided by 6 makes Y 8. 9 times 12 is 108, right? 108 divided by 18 makes that 6.
Or you could just simplify.
You can, Michael, but you got an extended proportion, but that's up to you. If you simplify, you're still going to. So in other words, here's the other idea between what I think Michael's saying. Proportional thinking means this. Fractions are being multiplied by the same number. So what do I multiply 6 by to get to 12? 2. What's 4 times 2? 8. What do I divide 18 by to get to 9? 2. Multiplied by 2. Yep.
I think I'll find that method easier.
Okay. So I'm going to stop presenting for a second. I'm going to stop recording. You guys can put everything away if you like. All right. That's where we'll pick it up tomorrow in terms of